Hi OpenXML developers, this is Eric White. I recently completed a chunk of work to support bidirectional text in the HTML converter module, which is part of Power Tools for OpenXML. The HTML converter module takes word processing ML documents and transforms them to HTML that is formatted with CSS. In the process of supporting bidirectional text, I had to understand the Unicode bidirectional algorithm, so I decided to record a screencast describing what I've learned about Unicode and the BiDi algorithm. The Unicode BiDi algorithm describes how text is displayed from left to right and right to left. And in addition to describing how to handle basic situations, it also describes approaches by which we can supply additional information about the bidirectionality of the text so that various edge cases, of which there are quite a few, are handled properly. The first key point about bidirectional text and text directionality is that text in a document, such as an HTML document or an OpenXML word processing ML document, isn't intrinsically left to right or right to left. By default, text is left to right, but that's because it's a default, not because it's intrinsically directional. Instead, one way to speak about this is that characters in a document run from the beginning of the document to the end of the document, and at various points in the document, characters are laid out left to right, and at other points in the document, characters are laid out right to left. And this layout of left to right and layout of right to left is done per the Unicode BiDi algorithm. First key point about the Unicode BiDi algorithm is that directionality of text is primarily determined by characters. Characters fall into one of three categories. They are either left to right, or they are right to left, or they are neutral with regards to directionality. In addition to directionality, in other words, whether they are left to right or right to left, they also have a strength. Most characters are strongly typed left to right or strongly typed right to left, but a few characters, primarily digits, and also some other characters that are used with numbers, these other characters are weakly typed left to right or right to left. There are some characters that are neutral in some circumstances, and in other circumstances they are weakly typed left to right. So as an example, decimal points and commas that are used in numbers, when they're used inside of a number, are weakly typed left to right. But if they are used outside of a number, in other words, if they're used in the middle of a sentence, then they are actually neutral with respect to directionality. And we're going to discuss how this strength and directionality figures into the BiDi algorithm. Let's take a quick look at an example or two. Here we have 4 paragraphs, HTML paragraphs. The first one's English, the second one is in Hebrew. In other words, it uses Hebrew characters which are strongly typed right to left. The third one is an English word, the English word of Hebrew. And the fourth is, again, another Hebrew word. And if we look over here at the rendering of this little bit of HTML, we can see the rendering of the left to right characters, and we can also see the rendering of the right to left characters. What we would see, for instance, here is that if I come down here and I delete this first character here, what that's going to do is that is going to delete this character right there in the Hebrew text. Let's go ahead and take a look at that. I'm going to press delete there, save it, and come back over here and press F5, and sure enough, that character is removed from the rendering of that Hebrew word. The next important concept that I'm going to discuss is that of a directional run. Most often, a directional run is a paragraph, but in HTML you can also have directional runs at the subparagraph level. Every directional run has a base direction. This base direction can be set at the document level, and it can be overridden at the block level, in other words, for a div or for a paragraph, and it can be overridden for HTML at the inline level. In other words, you can have a span that has a base direction. One thing to make a note of right here is that OpenXML Word Processing ML doesn't have directional runs at the sub-paragraph level. The base direction for text is set either at the document level or at the paragraph level. So here I have created a new paragraph. This new paragraph has a Hebrew word followed by an English word followed by a Hebrew word. And by default, this document is laid out left to right. That's because that is the default for an HTML document. And so if we look at the rendering of this document, we're going to see first this Hebrew word, then the English word, and then this Hebrew word. Let's take a look. And sure enough, this is exactly what we can see here. Now I've added a new paragraph here. This new paragraph replaces the word Israel with 1, 2, 3, 4, 5. And now we have a situation where we have a run that starts out with a Hebrew word. It then has some weakly typed left to right characters, and then it has the next Hebrew word. Let's take a look at how this renders. Because we have used weakly typed characters here, the Unicode Bidi algorithm sees this entire run of text as a unit, and it can lay out the entire run from right to left. We see here the first word in that paragraph as looking from the beginning of the document to the end of the document. In other words, the first word lexically in that paragraph is now laid out on the right. Then we have the digits, which are weakly typed left to right, and then we have the final Hebrew word, which is again laid out right to left. The next experiment that we make here is we can explicitly set the directionality of this to be right to left. Then, even though we've used characters here in the middle, this ISR AEL, which are strongly typed left to right characters, the entire run is laid out right to left. This is what I mean where we can set the directionality of the entire run as right to left by supplying this dir attribute and setting its value to RTL. In one case, because we used weakly typed left to right characters, the Unicode Bidi algorithm could take that entire span of text and lay it out right to left. In another case, because we specified the directionality, because we specified the base direction for that run, the Bidi algorithm will lay it out from right to left. Now, the Bidi algorithm also does some other things there, which is it makes it by default right justified, which was what you'd expect in a language that is rendered from right to left. As I mentioned before, the base direction for a directional run is inherited from parent HTML elements. So here we've set the base direction for a div to be right to left, And then we have a paragraph within that div where we've not set the base direction for that paragraph, but when we look at the rendering over here, we can see that, in fact, that paragraph was laid out right to left, even though it has strongly typed left to right characters in the middle of it. Here's another interesting experiment. In this bottom paragraph here, the paragraph itself hasn't had directionality set for it. It hasn't had the base direction set for it. Instead, I've set the base direction for a span within that paragraph where the base direction of this span is right to left. And when we see this rendered, we get this result over here in Internet Explorer. You can see that the words are still laid out from right to left. In other words, the words occur in exactly the same order as with the previous examples that we had. However, because the paragraph itself is still laid out left to right, because that is the default value here, we see that the paragraph is left justified by default. In this next example, I am showing another way to specify the directionality of a span of text. What we can see here is I'm using what's called the right to left embedding character. In other words, it's the RLE character, which is 202B in hex. At the end here, we have a 202C character, which is a pop directional formatting character. It's the PDF character. These characters have to be balanced. In other words, when you have one of these right to left embedding characters or a left to right embedding character, as the case may be, you must also have the matched number of pop directional formatting characters. In other words, this PDF character, the 202C at the end. These last two paragraphs are equivalent with regards to rendering per the Unicode Bidi algorithm. So let's take a look at that. And sure enough, we can see that these two paragraphs render exactly the same. So the directionality of the paragraph is still left to right. Therefore, the paragraph is laid out on the left edge of the display area. But the directionality of the run between those two characters that I discussed, that directionality is right to left, and this is functionally equivalent to encompassing all of those characters in a span and setting the direction to right to left in an HTML attribute. There are two different ways to accomplish the same thing. There are advantages and disadvantages to each. A disadvantage to using the left to right embedding characters and the right to left embedding characters is that you're obligated to balance those with PDF characters. Whereas when you have a span with a dir attribute, there's no issue of balancing it. You have a span and you have a closed span, and that itself is the balancing of those indications to the Unicode Bidi algorithm to lay out that run with a base direction of right to left. Now let's examine some edge cases associated with neutral characters. Here we have a paragraph, and the paragraph has a base direction of left to right, and that's because fundamentally this paragraph is in English, and the paragraph says, she says, and then there's a quote to him. So let's look at the rendering of this. So here's the rendering. You can say it says, she said, and then there's the word with the question mark on it, and then the person's name to him. And the question mark occurs in the right spot. It's to the left of the word that is meant to have the emphasis of being a question, and that's how it should be rendered in Hebrew. But let's modify this a bit. Let's change it so the person's name isn't there in Hebrew. Instead, it's she said this word and a question mark here to him. And when we look at how that's rendered, we see it looks like this. But this is not correct. The correct thing would be that question mark would come to the left of the Hebrew word, as it did in the previous sentence. But because the base direction of the paragraph is left to right, and because the question mark character is a neutral character, and the quote is a neutral character, and the space is a neutral character, and they're next to a strongly left to right character, the T in the TO, these will all be grouped together and be displayed as left to right. And so that means that the question mark comes in the wrong place there. It comes to the right of the Hebrew word. So now we can see how I've fixed this, and I'm introducing a new concept here. This is called an implicit marker character. This character right here, the 200F character. And the 200F character is an implicit marker character that is a right to left marker. So what that character is, it acts as a zero width character with strong direction. So now that 200F has a strong direction of right to left, it has the question mark right to the left of it in the file, and then there are other characters which have a strong direction of right to left, and therefore the Unicode Bidi algorithm will take all of these characters from this first Hebrew character all the way up through the implicit marker character and lay those all out right to left. And then the other portions of this sentence are laid out left to right, as you would expect. So let's see how this renders. And now we can see that the question mark occurs in the correct place. In other words, it should be to the left of the Hebrew word because that's where grammatically it should occur in this particular sentence. So these implicit marker characters give us a means by which we can indicate directionality of neutral characters that may occur between the implicit marker character and other strongly directional characters. There is another way to accomplish this exact thing. Instead of inserting an implicit marker character in there, we can insert a span with a dir attribute there with no content in the span at any particular location. And what this does is it does effectively the same thing as inserting the implicit marker character with a strong direction. It inserts effectively a character with zero width with a strong direction so that in this particular case the Unicode Bidi algorithm can group together the question mark here with the other strongly directional characters which are right to left in this case. So these are two different ways to accomplish the same thing. In the HTML converter, I always use the implicit marker characters. That's a cleaner solution for doing displays. It results in smaller HTML files. If you put a span with a dir attribute anywhere that you need an implicit marker character, it increases the size of the HTML file by a bit. Now let's do a little experiment here. I've taken out the implicit marker character that is a right to left mark, the 2000F, and I've put in an implicit marker character, a 2000E, which is a LRM, in other words, a left to right mark. Because this character here has a directionality of left to right, it's strongly directional left to right. In this particular case, it doesn't really matter whether it's strong or not. Because the whole paragraph is left to right directional, then that question mark is going to be put together with the quote and the space and the to him for display with regards to the Bidi algorithm. Let's take a look at the display of that paragraph. And here we can in fact see that that question mark then is grouped with the other left to right characters, and therefore that question mark comes to the right of the Hebrew characters. Up till now, I've tried to keep text in this example HTML document that could more or less make sense in the real world. Well, here I'm going to step away from that a bit just so that we can very carefully explore some aspects of the Unicode Bidi algorithm. Now I have a new paragraph here. It has a base direction of left to right, and then I have an English word followed by some Hebrew characters followed by another English word. It's going to display exactly as we'd expect it to display. It's going to have test to the left, then the Hebrew word, and then Israel to the right. So let's take a look at that. That's exactly what we see here. So in this next experiment, I have put in a 1, 2, 3 following the Hebrew characters. Because they are weak left to right characters, they bind to the right to left characters to their left. So when we see this rendered, we see it looks like this, that we see the test word, and then we see the Hebrew word, we see the 1, 2, 3 displayed in right to left order, and then finally we see the last English word, which is Israel. From this we can see that characters that have weak directionality, in other words the 1, 2, 3, effectively get their directionality from the characters that precede them lexically in the source document, lexically from the beginning of the document to the end of the document. So here is another experiment. We have a paragraph that has a base direction of left to right. We then have an English word, which is left to right characters. Then we have a span with directionality of right to left, and then we have a Hebrew word and an English word within the span, and then the paragraph ends. And what we're going to see here is the rendering of this will be test followed by the word Israel followed by the Hebrew word, because the words in this span are going to be laid out from right to left. And that's exactly what we see. Now here's an interesting experiment. We're going to put an exclamation mark following the Hebrew characters here. We're going to retain this span here, which is indicating that the directionality of the span is right to left. The entire paragraph is left to right, has a base directionality of left to right. So in this case, what we're going to see is we're going to first of all see the word test. Then we're going to get this run here laid out per the bidirectional algorithm right to left. And so that means the next thing that we're going to see here is we're going to see the word Israel followed by the exclamation mark followed by the Hebrew right to left characters. Because this exclamation mark follows the strongly typed right to left characters, it's going to be laid out with those characters, and therefore it's going to be adjacent and appearance-wise to the left of the Hebrew characters. So let's take a look at that. And here, this is exactly what we see. And for our last experiment, what we're going to do is we're going to put an implicit marker character, a left to right character, before the exclamation mark. So what we're going to have here is the entire paragraph is laid out with a directionality of left to right. We then have the word test coming first. We now get this span, which is going to be laid out from right to left. Because I've put in an implicit marker character, a left to right implicit marker character, this means that the exclamation mark is going to be laid out left to right with the word Israel, and then to the right of that we will see the Hebrew word. And that's exactly what we get. We see that the exclamation mark now is laid out with the word Israel because I have inserted an implicit LRM, which has a strong left to right direction. Well, that's all I'm going to cover in this video. What we have seen is that, to review, characters have a directionality. They are either left to right to left, or neutral. Further, they have a strength. They can be strongly left to right, or weakly left to right, or strongly right to left, or weakly right to left. The strength of the characters goes into the Unicode Bidi algorithm, and the algorithm uses the strength of the characters to group together, in effect, a span of characters to lay out as right to left or left to right. Sometimes, if there is a weakly typed directional character or a neutral typed directional character on the edge of a span that is going to be laid out as right to left or left to right, then those weakly typed characters or the neutral characters may get bound in effect to the wrong characters for laying out. They'll end up in positions that we don't want them to end up. So we can give hints to the Bidi algorithm. We can insert an implicit marker character, a left to right marker character, or a right to left mark character, which are zero width characters that have a strong directionality, which then the Unicode Bidi algorithm can use that to figure out whether those neutral or weakly directional characters need to be bound with right to left characters or bound with left to right characters for laying out of subspans within the entire paragraph or within the text itself. We can override the directionality of a span either by including a span element, an HTML span element with a dir attribute, or we can insert left to right embedding characters or right to left embedding characters, which then must be balanced with a pop directional formatting character. It's equivalent to inserting a span with a directional attribute. The two are functionally the same. We've also seen how we can, instead of using the implicit marker characters, we can insert a span with no text in it, but with a direction attribute on it, and that also will serve to the Unicode Bidi algorithm to indicate whether characters between that empty span and other characters will neutral characters or weakly directional characters in that range be laid out from right to left or left to right at large? I know it's a little bit complicated, but there it is. In the next screencast, I'm going to go through bits of the HTML converter module and explain how that module implements a transform from word processing ML to HTML with the appropriate implicit marker characters in there and the appropriate dir attributes so that we get exactly what we want. So we get an accurate transform of word processing ML to HTML. That's all I'm going to cover here. Thanks for watching. See you in the next screencast.